Good afternoon, everyone. Welcome you all to Center for Distance and Online Education, Arka Jain University. My name is Akash Kumar Bhagat. I am here to deliver a lecture on a subject Fundamentals of Digital Computers. I have completed my BTech in Electronics Engineering from Bengal College of Engineering and Technology, Durgapur, in the year 2012. Thereafter, I have completed my master's degree, MTech in Digital Electronics from Visvesvaraya Technological University, Belgavi, Karnataka. Presently, I am working as an assistant professor in Arka Jain University. I will be taking this course module wise. Today, we will start with module 2, machine learning, artificial intelligence, big data analytics. I have and IoT Arduino programming. I have published several research and international research papers in reputed journals, and presently I am working in this area of computer science and IT in the Arka Jain University, and today we will start with the module 2 of this subject, fundamentals of digital computers. So without wasting time, let's start. So this is a PPT presentation. With the help of this PPT, I will cover the second module of this course. Now, in this second module, we'll focus more in number system. So let's start. So this is your fundamentals of digital computer module 2. Now, we'll start with binary number system. So this is introduction to binary number system. We will learn the conversion between decimal and binary. As we all know that we have number system, we have decimal number system, which starts from 0 and goes on 0, 1, 2, 3, 4 like this. And we have binary number system. In binary number system, we have only two numbers, zeros and ones. So every number is represented in the form of 0 and 1. That is what your binary digits. So in binary number systems, we have only two digits. That's why the base of binary number system is 2. While in case of decimal number system, we have 10 numbers starting from 0 to 9. So base of decimal number system is 10. Later we will see the binary arithmetic, say addition, subtraction, multiplication, division, and we will also learn binary coded decimal representation. This is your BCD numbers. We'll also learn binary fractions, floating point representations up to complement representation. We will learn the binary codes like gray code, XS3 code. Next, learning objectives. What will be the learning objectives of this course? The learning objectives, we will explore the diverse applications of the computer in the fields such as business, healthcare, and entertainment. So, in this learning outcome, students will be able to learn the different fields such as business, healthcare, and entertainment at the end of this course. Business, basically we will do the analysis part of our study, our research area using this learning objective. Healthcare, in healthcare we will detect the various diseases in advance, in early stage of the disease. That will be known as the early detection of the several diseases. And different types of lab test, like lab diagnostic test, those will be performed with the help of the computers in the healthcare sector. Entertainment, different types of movies, various movies, music, this can be easily available through this computer system. Second, examine the profound societal impact of the computer on communication, education, and employment. So at the end of the course, students will have the idea of impact of computer on communication, education, and employment. So people are using computers in as a medium of communication. So medium of communication, people will send emails, they will get connected to each other with the help of video conferencing. Implementing this computer technology. Education, in educational institution, various research activities, different types of labs, simulation programs, various types of tests are being conducted using computers. Now, after learning these things, people will have the capability to get an employment. So people are becoming employable and they are using computers. To analyze emerging trends in computing technologies and ethical considerations related to privacy, security, and artificial intelligence. So people will analyze different types of computing technologies, the trending technologies, technologies which are happening in nature, which are very much popular in our day-to-day life, like Facebook, Google, Yahoo, WhatsApp. These are the things very common in our day-to-day life. So people will get to know how to develop a particular application, and parallelly they will be considering the ethical considerations related to the privacy of the data, related to the security of the data, and the implementation of artificial intelligence in various trending technologies. It is very important nowadays to ensure the privacy and the security of the data. Next, that is your introduction to the binary number system. Decimal number system, it is used in our day-to-day work. Like if you go to the market, you have to purchase 5 kg of rice. That is your decimal number system, 5 kg. For that you need to pay some say 300 rupees. This 300 is also a decimal number system. But what is binary? You have to convert this decimal number 5 kg, this 5 into the binary. What will be the binary equivalent of 5? That is your 101. That is your 101. Now, like this, we have to convert this 300 rupees, this number 300. This decimal number 300 has to be converted into a binary number in order to make it understand to the computer system. The computer only understand the binary language. Basically, language, we have categories like machine language, assembly language, high level language, and machine language are the languages which is written in the form of zeros and ones, while in case of your assembly language, it is written in the form of instructions, while as high level languages, these are the languages which is written in English like a statement. And we have the concept of compiler. We have the concept of compiler to convert a high level language or assembly language into a machine language. So this is the importance of this binary number system. As the computer understand only binary language are nothing but the machine language, the languages in which the instructions are written in the form of zeros and ones. Now 10 digits are used to 4 decimal numbers. Now how to use these 10 digits to 4 decimal numbers? Now how to represent these digits? 10 separate symbols starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 10 separate symbols. Only 2 digits, 0 and 1, are used to represent the binary number system. As I had already told you, the base of binary number system is 2. Here is, we can easily observe the base of binary number system, it is 2. And the digits 0 and 1 are called the bits. That is nothing but the binary digits. In this number system, the value of the digit will go 2 times greater than its predecessors. Now, whatever is the current value, it has to be multiplied by 2 and deliver the next value. So suppose the current value is 1. So 1 will be getting multiplied by 2. 1 into 2, 2. Next 2 into 2, 4. 4 into 2, 8. 8 into 2 equal to 16. 16 into 2 equal to 32. And so on. Like 32 into 2 equal to 64. Again 64 into 2 equal to, I have written here till 32. Now 64 into 2 equal to 128. Next, weights in binary number system. So what are the different weights that are available in the binary number system? Weights of each binary digit depends on the relative position within the number. It is explained by the following example. So let us consider an example. Now the weights of the bits binary number 10110. Now consider these weights are, say it is 0, then write 1, 2, 3, 4 like this and put it in the power of 2. So 2 to the power 0 into 0. Next 1, 2 to the power 1 into 1. Next 2, 2 to the power 2 into 1. Next 3, 2 to the power 3 into 0. 4, 2 to the power 4 into 1. So whatever is the binary digit that is available in this sequence, your weights, after putting your weights on the power of 2, it has to be multiplied with the sequence, the binary number that is given. And why 2? Why we are putting the weights of this binary number while converting this binary into the decimal? Why this is a conversion of binary number system into the decimal number system. Why we are putting 2? Because the base of binary number system is 2. There are only 2 digits, 0 and 1. So these 2 is playing an important role. Now evaluate this 2 to the power 4, 16 into 1, 16 only. Now 2 to the power 3, 8, 8 into 0, 0. 2 to the power 2, 4, 4 into 1, 4. 2 to the power 1, 2, 2 into 2, 2. 2 to the power 0, 1, 1 into 0, 0. So 16 plus 0, 16, then 16 plus 4, 20, 20 plus 2, 22, 22 plus 0, 22. So this is your decimal number. So what is the decimal equivalent of 10110? It is 22. Next. Conversion of decimal to binary. Conversion of decimal to binary. So how to, in the previous example, we have studied how to convert a binary number into the decimal number. Now we will study how to convert a decimal number into a binary number. So convert this 75. 75 is a decimal number. We have to convert it into its binary equivalent. So what is the method? Method is very simple. We have to divide this 75 by 2 and we have to note down the remainder. So on dividing this 75 by 2, so 2 3 is a 6, 6 again remainder 1, then 5, 15. So 2 7 is a 14. And the final remainder 1. Now similarly we can divide 37 by 2, we will get remainder as 1. Now again we divide this 18, 18 by 2, 18 nines are 2 nines are 18. So remainder is 0. Again we divide this 9 by 2, 2 fours are 8. Remainder is 1. Now 2 it will be getting divided by 2, 2 twos are 4. Remainder 0. Now 2 ones are 2. 2 is getting divided by 2, 2 ones are 2. Remainder 0. Why this 2 also we have to divide? Because we have to get this dividend. Now after this, go in the reverse direction, say 1 0 0 1 0 1 1. So read in reverse order. After completing the division, when it is not possible to divide the number by 2 anymore, then we consider the reverse order of the remainder, and we found 1 0 0 1 0 1 1 1 0 0 1 0 1 1, and this is the binary equivalent of the decimal number 75. Next, now this is your input output model. In this model, what is the decimal equivalent? It is 0. Binary equivalent is also 0. What is the decimal equivalent? It is 1. Binary is also 1. For 2 it is 1 0. For 3 it is 1 1. For 4 it is 1 0 0. For 5 it is 1 0 1. So I had explained at the very beginning of this class, 5 it is 1 0 1. For 6 1 1 0. For 7 1 1 1. For 8 1 triple 0. For 9 1 0 0 1, and so on. So these are the decimal number and these are their binary equivalent. Next, binary arithmetic. So we all perform all arithmetic functions starting from addition, subtraction, multiplication, division. We perform all arithmetic function. Addition. Adding two binary numbers will give us the binary number itself. What will be the result of a? What is the result of addition of two binary numbers? Say 0 plus 0, it is 0, and 0 plus 1, 1, then 1 plus 0, 1 plus 0, 1, that 1 plus 1, 1 1 0 carry 1. So this is the binary addition. Now binary subtraction. Now subtracting two binary numbers will give us binary number itself. It is also a straightforward method. Subtraction of two single digit binary number is given by, so 0 minus 0, it is 0. 0 minus 1, it is 1 with borrow 1. So if it is 0, you have to subtract 1 from this 0, not possible. You borrow 1, so it will become 1 0. So the decimal equivalent of 1 0, it is 2. Now 2 minus 1, 1. So on borrowing, the result is 1. Now 1 minus 0, 1. 1 minus 1, 0. Now binary multiplication. Multiplication process is same for the binary numbers as it is for numerals. Let us understand with this example. Multiply 1 1 0 1, a binary number, with another binary number 1 0 1 0. So next, division. It is similar to the division, decimal number division method. We will learn with an example here. Divide 1 0 1 0 by 1 0. So how to divide? So we have to divide 1 0 1 0 by 1 0. So dividing by 1, you got 1 0, remainder is 0. Then again 1 0 is carrying, 1 is carrying, it is not getting divided. 0 1 is not getting divided by 1 0. So you have to carry one more. And once you have taken this 0 down, you have to put a 0 here in this place, and afterwards it is getting 0. So this 1 0, it is becoming 1 0, and this 1 0 is getting divided by 1 time, so it is 1 0. So into 1, 1 0 into 1, 1 0, result is 0. Result is 0. This is the binary division. Next, functional components. The main component in a computer explained as follow. The memory. So MU, memory unit, is the most important component. It is responsible for storing the data, whether it is inside or outside the system. So for example, this memory is categorized into two categories. First one is primary memory and second one is secondary memory. In primary memory, we have RAM, ROM. In secondary memory, we have pen drive, hard disk drive. So it is your RAM and ROM. What is RAM? RAM is actually non-permanent, it is a volatile memory. The data stored in a RAM will continue as long as the power supply is there. Once the power supply is off, the data will simply escape from the RAM. Now, storing the data, whether it is inside or outside the system, has the following two types: primary memory and the secondary memory. Now, basic units of measurement. Bit is the unit of information equivalent to the result of a choice between two values in a binary number system. I have already told you, either 0 or 1. Now, byte is a sequence of 8 bits. So, 1 byte equal to 8 bits. So, enough to represent one character of alphanumeric data possessed by a single unit of information. Next. Now, how these signals are getting converted into the binary format? Suppose you press 1. So, this 1 is getting converted with the help of a CPU electrical signal, this A. The keyboard from it is coming, it is placed on the keyboard A, and yes, it is getting converted into a binary code with the help of the CPU, and that code is getting again as an input to the monitor. Now the monitor will simply convert it to the display and it will be showing A. Next, see, 1024 bytes equal to 1 kilobyte. Either you write K or KB. Now 1024 KB equal to 1 MB, that is 1 megabyte. 1024 MB equal to 1 GB. Now 1024 GB equal to 1 TB, terabyte. So this is what the basic units of measurement in computer science. Now features. So the features already these are discussed in details. Speed, accuracy, storage, versatility, reliability, automation. These are the features. Now, history and evolution. The first generation we considered from the year 1940 to 1956, and the technology that were used in the first generation of computer was vacuum tubes. Now, these vacuum popular technology names were Mark I ENIAC. Second generation, it is started in 1956 till 1963. The technology which was used for the second generation was transistors, IBM 1401. Third generation. Third generation is 1964 to 1971. That is integrated circuits era. And the technologies were influenced by integrated circuit. The examples of programs were Fortran programming, COBOL. Fourth generation, it is started in 1972 and it lasts till 2010. And the technology which were very popular during the fourth generation was microprocessors. Next, fifth generation. It is started from 2010 and still it exists in nature. Fifth generation, what we are talking about, artificial intelligence, machine learning, IoT, these are our fifth generation AI. Now, next, these are the assignment questions. What is a computer system? What is system unit? Explain with the system unit with diagram. Write 5 input devices and also explain its working principle. Explain computer operations. Explain characteristics of computer. Explain processor with a block diagram. These are the sample questions. Now this computer operations and the processor operation. So in computer operations, we have these different steps, say fetch, decode, execute, store, read and write operation. So there are multiple operations performed by the computer or processors, say starting from the fetch. So whenever any data or instructions we want to execute, it has to fetch from the memory. So we have to fetch that instruction or data from the memory. After this fetch option, we have to decode. As I had already explained, the processor, it has to convert the decimal number system into the binary number system in the form of code. So this is known as decoding, and after decoding we have to execute. So we have to execute on different excels, on different processor, the execution on using different compilers. Now once the data is executed, we have to store these instructions, and after these storage, how to store these instructions, we can use the write operation. So we have to write our data in the memory, and once we have written and we have saved it, we can easily retrieve the data, or we can easily read the data. So this is all about the computer operation and the processor operations. That was very much important. Later on with these operations only, we have to work on the parallelization, we have to work on the pipelining architecture. So these are the things. Now these are the assignment questions. Note down these few assignment questions. Conclusion. We can come to the conclusion that yes, obviously computer is an electronic device that is used to perform a variety of operations based on a set of instructions called program. Takes the input from the user, convert it into the binary language, process it by the computer. Again, it will convert the data, the processor output, which is again in binary language. That output has to be converted back to the high level language, and it will be delivered to the human beings. Now computer performs a great speed and have the capability of processing even the most complex computations in a matter of seconds. So I have also discussed the range of today's processor. It is of gigahertz, so it is 10 to the power 9 gigahertz. So that means 10 to the power 9 instructions are executed per second. So if you consider this and calculate the time period that is required by one processor to be executed, so it will be 1 upon 10 to the power 9. So 10 to the power minus 9. So it is nothing but the time required to complete instruction using this method. It is 10 to the power minus 9, that is nano. So 1 nanosecond is required to become this, to complete the execution. Thank you. Thanks for listening patiently. Thank you so much.